We'll be learning about logistic regression and the mathematics behind this machine learning algorithm. So regression is the term which we use usually to predict some values, right? Predict some values. Even in linear regression, what we do is we have the linear regression expression as y equal to mx plus c, right? Or b, or there are many forms of this equation. So this is the intercept or the bias, and this m is the weights. So what we usually do is we predict this m and we predict this c, put it in this equation, and we predict the y, right? The x is usually given as the feature. That's what we do in linear regression. Now in logistic regression, we predict the probability values, right? We predict the probability values, hence it is called a regression, because here also we are predicting some values, hence it is called logistic regression. Logistic regression is usually used for classification problems where we predict if the email is spam or ham, if the person is gonna default in the loan, or if it is not, if he or she is not gonna default, if it is gonna rain or if it is not gonna rain. It's usually used for binary classification. Now lot of question arises is if we are predicting values like this is the probability we are predicting, then why can't we use this same linear regression equation, which is mx plus c, or it can be written as w transpose x plus b, right, where w is the weights and b is called either the intercept or bias, right? If we are predicting the values, we can simply use this equation. We can predict the weights and the bias, plug it in this equation, and we'll get the y value, right? It works. Let's see. Now here is the two-dimension graph. Here is the 0 and this is the y-axis, so this one will be 1. Yeah, since y is the probability value, I'm sure you guys know what does probability means. So if in a nutshell I have to tell you what probability is. So suppose the probability is 0.7, so we can scale it up to 70%. So there is a 70% chance if we are predicting about rain. So there is a 70% chance it's gonna rain. There's a 30% chance it's not gonna rain. It's not gonna rain. So this is what is it's basically the measure of possibility, right? So here also we'll have a value from 0 to 1, and this is the x variable. Now think like that, the x can take any values from minus infinity to plus infinity, right? Now suppose we get a line like this, yeah, and here we are predicting if a person has diabetes or not. So suppose this is the value 100, and we are going to take as this 0.3. We are going to take the cutoff as 0.5. So a person is diabetic only if it is more than 0.5. If it is less than 0.5, he is not diabetic. So 120, suppose we are taking. So the classifier is predicting is at somewhere at around 1.5, above 1.5, he is diabetic. Yeah, lesser than that, not diabetic, more than that, diabetic. So the line is working pretty good, no problem as such. But Suppose we have a data point somewhere here. We get a new data point somewhere here. Now this best fit line will somewhat change like this to adjust this point. Now see this one or this one, 120. Earlier our best fit line was predicting this as diabetic, correct? 120 above diabetic, and now this best fit line is predicting as 0.3 probability. That means the line is predicting that the person does not have diabetes. So this is a misclassification, right? Again, if the point lies somewhere here, the best fit line again has to move from here. So there are number of best fit lines we'll be making in order to classify some points, right? So this is clearly not gonna work. Again, another thing, as I said, x can take a value from minus infinity to plus infinity. Now suppose x is somewhere, we can extend this line, right? X is somewhere here. What will be the y? The y will leave this point and it will go somewhere here, which does not make sense, right? Because this is the probability. The probability can't have a value over 1, right? So again, clearly linear regression is not a solution for logistic regression, for a classification, binary classification problem. So I'm gonna get another sheet. Now I'm gonna introduce to a function which is known as sigmoid function. To overcome the problem which we saw earlier, I'm going to introduce to this function which is a sigmoid function. Now a sigmoid function equation is P is equal to 1 by 1 plus e to the power minus y. This is the equation for a sigmoid function. Here we also do the same thing. We learn the weights and the bias, plug it in, and we get the probability. Here y equal to WTX plus B. Here also we do the same thing. We learn the weights, we learn the bias, and then we predict y. And then we plug it in here and we get the probability. Now this equation comes with a graph, of course. I remember the graph. It goes like this. Okay. So this is 1, this is 0, and this is 0.5. Yeah, these two points are called as asymptotes. So what are asymptotes? Asymptotes are points where it's said that it is gonna meet at infinity. It reaches the infinity but does not meet this point. Yeah, it meets somewhere in the infinity. These are called the asymptotes. Yeah. Now when y is equal to infinity, if we plug y equal to infinity, this expression becomes e to the power minus infinity. When e to the power minus infinity is equal to 0, we all know that, right? So here this expression becomes 1 plus 0, that is 1. So p here becomes 1, right? P becomes 1. Now when e is minus infinity, when y is minus infinity, e to the power infinity is infinity. 1 plus infinity is infinity. P becomes 1 by infinity, which is equal to 0. Now when y is equal to 0, when y is equal to 0, e to the power 0 is 1, 1 plus 1 is 2, p becomes 0.5. Hence this is the curve, right? So I'm gonna remove this one. So here we can see the logistic regression model estimates the probability that an instance belongs to a positive class. See, when it is above 0.5, the classifier predicts it that the instance belongs to 1, that is a positive class, and less than that it predicts that the instance does not belong to a positive class. That means the instance belongs to 0. We can see this from the sigmoid curve equation, right? Now we'll be proving something about the odds. Logistic regression, this odds play a very essential role. You'll see how. So odds means we say right, what are the odds that it's gonna rain? So there's a 70% chance it's gonna rain. So odds are defined as the ratio of success to the ratio of failure. Okay, so this can also be written as P upon 1 minus P. So the odds that in a flip of coin you get head is 0.5. So we define odds as probability ratio of probability of success by failure. Now I'm going to let you know why this equation is important. So let's see. Now here we said odds equal to P upon 1 minus P. Yeah. So here we are predicting what are the odds that the patient is diabetic. Here diabetic is classified as 1, non-diabetic is classified as 0. So we are predicting what are the odds that the person is diabetic. So this can also be written as odds y is equal to 1. Yeah. This can also be written as equal to P by 1 minus P. From the expression that we learned earlier, this P was written as P is equals to 1 by 1 plus e to the power minus y, right? Now we can plug this equation in this equation and find out what are the odds. Let's see that. So odds can also be written as 1 by 1 plus e to the power minus y divided by 1 minus 1 by 1 plus e to the power minus y. Let's solve this and we'll see something really amazing. This equation, if we solve, it becomes 1 by 1 plus e to the power minus y divided by e to the power minus y by 1 plus e to the power minus y. Again, if we simplify this equation, these two cancels out, right? So it becomes 1 by e to the power minus y. Okay. Now if we take this y in the numerator, this was in the denominator, if we take it in numerator, it becomes e to the power y. So odds of a person being a diabetic, one being in the positive class, is e to the power y, and y from the equation we know is W transpose X plus B. This equation can also be, we all know linear equation can also be written as beta naught plus beta 1 x1 beta 2 x2, which goes on to beta n xn. Now to remove this exponential, we can add log to both sides. So log of odds of y is equal to this equation. Yeah, so here the key ingredient are the logistic response and the logit, right, in which we map this probability which is on 0 to 1 scale. This is on 0 to 1 scale, which we are mapping this probability to a more expensive scale suitable for linear modeling, right? So that's what logistic regression is. In the next video, we'll learn more about the log loss function and of course the maximum likelihood estimation, which is used to find the best sigmoid curve to fit equation. Do come back for more exciting maths and machine learning and share the video if you find it interesting. I'll see you soon.